For years, the centerpiece of American deep space exploration was the Lunar Gateway, a multi-billion-dollar space station designed to orbit the Moon. In March 2026, NASA canceled it. NASA Administrator Jared Isaacman placed the orbital project on an indefinite pause. Instead of building a way station in space, the agency is directing all of its engineering resources down to the lunar dirt. China has set a hard deadline to land its own taikonauts on the lunar surface by 2030. To maintain its strategic edge, the United States needs an active, physical presence on the ground before a rival coalition establishes one. This flowchart outlines the new strategy, known as the Ignition Initiative. It tracks how NASA is taking the $20 billion originally slated for the orbital station and directing it to the lunar South Pole to construct a nuclear-powered settlement. Orbiting the Moon leaves no physical footprint. To secure a lasting geopolitical advantage, a nation has to actually hold the territory. This bar chart displays the payload targets for Phase 1 of the Ignition Initiative, running from 2026 to 2028. NASA will deliver 4,000 kilograms of hardware through 24 rapid-fire robotic launches. Among that early cargo is Viper, a mobile robotic rover designed to prospect for resources. Its specific job is to drive into permanently shadowed craters and hunt for subsurface water ice. To map areas too hazardous for wheels, NASA is sending moonfall drones. These are propulsive helicopters modeled after the Ingenuity aircraft used on Mars, built to scout the jagged terrain for potential habitat sites. All of this robotic scouting culminates with Artemis 4 in 2028. A human crew will land directly at the South Pole to physically prepare the site for heavy construction. NASA is discarding the old model of launching isolated, custom-built science missions. Phase 1 introduces a strict, templated rhythm of industrial delivery. Looking at the updated chart for Phase 2, which spans 2029 to 2032, the mass delivered to the surface spikes to 60,000 kilograms. This massive jump supports an aggressive schedule of 2 crewed landings every year. Astronauts will arrive to find a functioning surface grid. Robotic missions will have already deployed localized GPS networks, cell towers for communication, and massive solar arrays. Because solar power is useless during the long lunar night, NASA will also deploy early-stage nuclear technology to serve as an independent backup power source. The primary vehicle for this phase comes from JAXA, the Japan Aerospace Exploration Agency. They are providing a pressurized rover, a vehicle with a breathable internal environment that allows astronauts to explore without wearing heavy spacesuits. By 2032, the lunar South Pole will transition from a hostile vacuum into a networked, semi-habitable zone equipped to sustain longer expeditions. The final state of our data visualization shows Phase 3, beginning in 2033. Using heavy commercial cargo landers, NASA will drop 150,000 kilograms of infrastructure onto the Moon. This mass includes pressurized living modules from Italy called multi-purpose habitats, alongside Canada's lunar utility vehicles, which serve as heavy-duty cargo carriers on the surface. To keep these sprawling facilities and their crews from freezing during the 14-day lunar nights, the base will rely on megawatt-class nuclear fission reactors for continuous heat and electricity. The supply chain will eventually move off of Earth entirely. The base will utilize in-situ resource manufacturing, running raw lunar dust through 3D printers to produce base infrastructure directly on site. With in-situ manufacturing and megawatt-class power online, the South Pole site functions as a self-sustaining industrial facility. By the late 2030s, the Moon base will function as an active piece of human real estate, fully powered and continuously occupied. The Ignition Initiative serves as the primary technical validation program for the systems required to reach Mars. The drones, 3D printers, and fission reactors established at the South Pole are identical to the hardware slated for the SR-1 Freedom mission. SR-1 Freedom is a nuclear-powered spacecraft designed to carry heavy freight and scout helicopters to the Martian atmosphere. Before loading that hardware onto a ship bound for another planet, NASA needs an unforgiving environment to test its limits. The extreme radiation and vacuum of the lunar South Pole provides an indispensable testing ground. The Ignition era is built on the installation of permanent physical infrastructure that ensures human occupancy of the Moon remains continuous.